Hi, welcome to Module 8, which is on a second part of our three-part algebra review, and it's on solving equalities. Now, we're going to solve two kinds of equalities today, the only kinds you'll probably be expected to solve most of the time in practice as a political scientist or social scientist, linear equalities and quadratic equalities. You can go on forever with higher and higher powers of things, but they get harder and harder to solve by hand, require some fancy factoring, and typically people will just use a computer or something else to do that for you. So we're going to focus on linear and quadratic. What are those terms? Now, we'll talk about them in much more detail in the next video lecture on functions, but for our purposes, it helps to have some small definition knowledge so we can solve things, so we'll do that. A linear equation is one that involves only the first power of things. So, let's start with one. Y equals, 3x plus 7. There is a linear equation. It involves only the first power of y and the first power of x. Now, let's say you want to solve for x. What does that mean? Well, first note that an equality means the stuff on the left, which we'll often refer to as the LHS for left-hand side, is the same as the stuff on the right of the equality, which we refer to as the right-hand side, or RHS. If you see those terms in any kind of book or reading, that's what they mean, left-hand side and right-hand side of the equation. So, right now the equation is solved for y already. Right? So, there's a y on the left and other stuff on the right. If the y is isolated by itself, that means we've solved for it. We have the y explicitly laid out for us. But what if we want to solve for x? Right? What if we want to solve for x? Well, to do that, we make use of the fact that an equality means everything on the left-hand side is the exact same as everything on the right-hand side, the exact same terms. Right? So y here is the exact same thing as 3x plus 7. What that means is, if we do something to the left-hand side, say multiply by something or subtract something, and we do the exact same thing to the right-hand side, the equality still holds. Right? So let's just take a look at that. Right? So if I have, it's easier to see if you have numbers, right? So if I have 3 equals 3, right, they're the same thing. If I multiply the left times 2, and the right times 2, here I'm using the fact that multiplication is commutative, so I can multiply them like that. Then over here, I get 6, and over here, I get 6, and they remain the same. So that's good. Right? So that's, in general, how you solve equalities. You manipulate both sides in the exact same fashion until you end up with the thing you care about by itself. Let's start with a simpler example than the top one first. Okay. So let's say 2x plus 7 equals 0. There's a nice linear equation. We're saying 2x plus 7 equals 0. What is x? Right. This is probably the first kind of algebra you've ever done, assuming you've done it before. And you do it by manipulating the equation to get you x by itself. How do you do that? Well, people have different ways of doing it best. So when I first learned how to do this, they taught it in the way that I'm going to explain it first, and I had trouble with it, and then I just started moving things around, and that worked better for me. Different people have different ways of doing it. I'm going to give you the more standard way right now, which is to operate both sides in the same way and keep track of that operation. So I want x by itself. How do I do that? Well, there's two problems here. One, I got a 7 off on the left-hand side with x, and the second one is I have a 2 multiplying x. I don't want either of them. And so what I do is I use the inverses of those things to get rid of the 2 and the 7. Now remember, a few modules ago we talked about PEMDAS, and that's the order of operations, parentheses, exponents, multiply, divide, add, subtract. But when I try to isolate an x, I'm going to go that in reverse. I'm going to get rid of the things that operate last first. So first I'm going to do the addition. I'm going to get rid of that 7. How do I do that? Well, the additive inverse of 7 is negative 7. So if I add negative 7 to both sides, the 7 on the left-hand side will cancel. So how does that work? Well, I add this equation to both sides. I'm adding equations now because equations mean the same thing is true on both sides. So if I add to both sides the same way, I'm okay. The plus 7 and the minus 7 makes 0. So I get 2x plus 0. 0 plus negative 7 gives you negative 7. I can get rid of the 0. Now I have 2x equals negative 7. Okay, the 7's gone. What about the 2? Well, now I go backwards again, multiplying. Now I need a multiplicative inverse. And what we said for that was the multiplicative inverse was 1 over the number. So let's multiply both sides by a half. And I can multiply by the equation a half, but again, that's not that important. A half times 2x, remember associative means this is the same thing as a half times 2 times x, and this is negative 7 over 2. Well, the 2 times a half is 1, so that equals just x, and this side is negative 7 halves, and we're done. So we have x equals negative 7 halves, and we've solved the simple linear equation. And we do that by reversing the order of operations and using inverses on all the operations to move them from the left side to the right side, or at least away from the x. Okay. So now let's go back and do the example we did before with the y in it. And it turns out the y affects nothing. So we add and subtract 7 from both sides. Sorry, we add negative 7 to both sides. So this side is y minus 7. And this side is 3x plus 7 minus 7. These two things cancel. Now I have 3x equals y minus 7. Again, I can flip left and right whenever I want to because they're the same thing. A equals b means b equals a. So now I have a 3 here on the left. I multiply by 1/3. So I have 1/3 times 3x equals 1/3 times y minus 7. Now remember the parentheses appeared here because the 1/3 multiplies everything on the right side. So the parentheses means I want to multiply everything on the right side at the same time. I could have also distributed that 1/3, which looks like this. Those are the same things because of the distributive property. This side, 1/3 times 3, by the associative property, is just x. So I have x equals y over 3 minus 7 over 3, or I could have written this factoring out, it's called the 1/3, like that. And we're done. The y here has no role. It doesn't matter that it's a y or a number. You can do all this as arithmetic with only numbers or as algebra with variables. It does not matter, right? If I had numbers for everything, it'd be really easy, right? I would say if x equals 2, I could find y. Well, I could plug in 2 and get y equals 6 plus 7 equals 13. Or I could have written y equals 2 and solve for x. This equation would tell me y is 2, so x equals 1/3 times 2 minus 7. Parentheses first means this is 1/3 times negative 5, or negative 5/3. I go off the page. That's it. So all these operations, doesn't matter if they're numbers or variables or constants or whatever, they all work just fine. And all linear equations work the same way. You can just move things around and isolate the one you care about and solve that way. That's it for linear equations. And the most common ones you're going to deal with. Now, you also deal with quadratic equations sometimes. Quadratic equations are a little more complex. So let's do one. Because they don't always have solutions that are real solutions. So let's say x squared minus 1. There's a quadratic equation. And we'll make it easy and say that's equal to 0. How do you solve for x here? Well, there's two different ways we're going to talk about. The first, and there's lots of different ways actually, but we're going to talk about two of them in this video course. You'll find more in other places as well. The first way is via factoring. And factoring can be done just by noticing the factoring or by completing a square. We'll just do the noticing part right now, and then you can look at more stuff later in the book and elsewhere. So how do you factor? Well, factoring means separating out a squared term into linear terms, right, or smaller terms in general, right? This is called a polynomial, which we'll talk about polynomials in general, or do functions shortly. But a polynomial is a bunch of variables raised to powers. X plus 1 is a polynomial, x squared minus x plus 2 is a polynomial, x cubed plus 7 is a polynomial. Those are all polynomials. They have more than one term, effectively. Let's go back here. Okay, so factoring means taking a polynomial like this and splitting it up into multiplied smaller polynomials. One way to do this is by trial and error. That's tricky if you don't have much experience in this, but in this case, x squared minus 1, I think, okay, well, what could be x squared minus 1? What should be the terms in the polynomial? Well, I want two terms. I'll put in parentheses. I want to have linear because they have to be smaller, so let's put x's here. And what can I put in here to make this work? The thing in the middle there is a plus or minus. Plus or minus means it could be plus or it could be minus. You don't know the sign. That's a symbol that means that. Okay, so now we have x plus or minus a times x plus or minus b. That's really general. We know how to produce that, but what's a and b? Do we have an a and b we can actually use? Well, let's check. To figure that out, we can solve this. We can expand this factor via the FOIL method. First, outer, inner, last. So first you multiply x times x. So let's see if I can get different. So here's the first. So you have x times x is x squared. Now let's change the color. Now the outer. And to be perfectly honest, I don't. Oh, I see. Yeah. So I'd never do this particular way, so forgive me. That equals x times b, the two outer terms. That's plus or minus because this could be a minus or a plus. Remember, or haven't said it yet. So if you have a negative number times a positive number, the sign of that is negative. If you have two negative numbers, the sign is positive. So x, which is positive, times a negative or a positive, might be negative or positive, so we'll leave that like that. xb, inner, the two inner ones, so it's again a plus or minus x a. And the last one is ab. This is always plus. Sorry, there's a plus or minus as well, because this one could be plus, this one could be minus. So this is what we get. We multiply out. First means the first one needs parentheses. Outer means the first and the first times the second and the second. Inner means the second and the first times the second and the second. And I totally violated the whole color thing. Apologize. And last means the last one in each parentheses. Gives you this multiplied. I put the a there. You'll find that when you go to the board to do things in any class you have, that when you go to the board, or in this case a tablet, your ability to do math drops precipitously. So I'm going to apologize ahead of time for mistakes, and rather than try to re-record this over and over again, I'm going to just keep talking. So here is the expanded version of this factor. What do we do with this? Well, okay, this has to equal x squared minus 1. Okay, so what do we do with that? Well, x squared equals x squared, so that's great. We took care of the x squareds. They're the same on both sides. Now, there's nothing with x on the right. So when we add plus or minus xb to plus or minus xa, we have to get 0. So plus or minus b plus or minus a times x, because both of them are multiplied by x, we can pull the x out using the distributive property, has to equal 0. That means plus minus b plus a equals 0, or a and b have to be additive inverses. So if one's a, one's negative a. Right, because a minus a would equal 0. Or negative a plus a equals 0. So let's call b negative a. They're additive inverses because otherwise they can't add to 0. So that's done. And then we just have b times a equals negative 1. Well, how do you get two things to equal negative 1? They're additive inverses. Well, if one's 1 and one's negative 1, then they're additive inverses. They add to 0, but they multiply to give you negative 1. So let's say a is 1 and b is negative 1. And finally, we can write this as x plus 1 times x minus 1. And you can go ahead and check that. X times x is x squared. X times outer. X times negative 1 is negative x. Inner, 1 times x is x. X plus negative x is 0. Good. And 1 times negative 1 is negative 1. So we get back what we wanted. What did this get us? Well, the original equation was x, so let's clear this. The original equation was x squared minus 1 equals 0. We factored this to get us x plus 1 times x minus 1. Since it's the exact same thing as x squared minus 1, this is still 0. Now, if you multiply any number times 0, you get 0. So, if this equals 0, that means either, or both, well, it's hard in that case to be both, either x plus 1 equals 0, or x minus 1 equals 0. And we have two linear equations to solve. Well, how do we solve them? Well, we can add the same number to both sides. So x plus 1 minus 1 equals 0 minus 1, or x equals negative 1 is one solution. And x minus 1 plus 1 equals 0 plus 1, or x equals plus 1. Again, I added negative 1 to both sides in the first case, and positive 1 to both sides in the second case. And we now have two solutions. X equals negative 1 or 1. There's a set of solutions which we can draw, which we can say x is in the set negative 1 and 1. And those are that's the solution set for the equation x squared minus 1. And that's one way to solve it, is by factoring. This way works really well when you have something that factors well, or you can recognize how it works, right? So for instance, another quick example, x squared plus 2x plus 1 equals 0. What's this? Well, it seems more complicated at first, but we can check something really fast, and you can do the previous procedure again if you wanted to, but let's just square this real fast. Well, this equals x plus 1 times x plus 1. If with the 1. That means, so first is x times x. Outer is x times 1. Inner is 1 times x. And last is 1 times 1 equals x squared plus 2x plus 1. So that's the factoring for that. So now we have to make x plus 1 equal to 0, which we've already shown means x equals negative 1. So there's only one solution to this particular one, which is x equals negative 1. And that's one way to solve them. The second way, I'm sorry this one's running a little long, this module, is to use what's known as the quadratic equation. The quadratic equation can be derived pretty simply by completing a square. We talked about that a little in the book, but it's easier if you just remember it. If you have an equation that looks like this, the solution to this is x equals negative b plus or minus, because as we saw, there could be two solutions to these equations, b squared minus 4 times a times c divided by 2a. This equation is helpful, the quadratic equation, because you can plug in anything you want for these values and get the answer pretty quickly. So for instance, the example we did, if x squared minus 1 is our example, a is 1, b is 0, c equals -1, we can plug into the quadratic equation and get x equals 0 plus or minus the square root of 0 minus 4 times 1 times -1 over 2 times 1. Negative times negative is a positive. So we get x equals, down here, x equals, create the 0, plus or minus the square root of 4 divided by 2. We haven't mentioned square roots yet. We'll do a little more in the function part, but a square root is the inverse of a square. So if 2 squared is 4, the square root of 4 is plus or minus 2. Why plus or minus? Because -2 times -2 is 4, because the two negatives cancel, and +2 times +2 is 4. So you can't tell if it's a +2 or -2, so the square root of 4 is plus or minus 2. There's two possible solutions to that, two possible values of that. So here we have plus or minus 2 over 2, which equals plus or minus 1, which was the solution to our equation. And just to be absolutely complete, first I kind of erase over here, which is kind of sad. If we have x squared plus 4x, x squared plus 2x plus 1, then you have x, then if you plug it in, x equals, let's see, a is 1, b is 2, and c is 1. Then you get -2 plus or minus the square root of 2 squared, which is going to be 4, minus 4 times 1 times 1. 4 minus 4 is 0, times 2 times 1. That equals -2 plus or minus 0 over 2, which equals -1. So only one solution to that, which again matches our previous answer. This method is slower if the factoring is easy, but faster if the factoring is hard. You can use whatever method you want to do all this stuff yourself. And again, there exist tons of programs on the internet that you can do this for you, but it's helpful when you're doing math yourself, not to have to turn to a computer for the small stuff. That's it. And so next time we'll do a little more on simplifying equations, including inequalities. Thank you.